Let's consider Lewis dot structures. The Lewis dot structures will tell us the number of covalent bonds between atoms. So let's do an example. Let's consider the water molecule, which we know is 2 hydrogens and 1 oxygen bonded together. Lewis dot structures, hydrogen are almost always on the outside of a molecule. And so that would mean oxygen would be in the center. So we put oxygen in the center, and we put the hydrogens on the outside. We're going to represent the electrons as dots on paper. So that's why it's called Lewis dot structures. And so in order to know how many dots and the arrangements to put around the atoms, we look at the electron configurations. Oxygen has the following electron configuration. I'm going to draw the configuration in this manner, this graphical manner. So we have 2 electrons in the 1s, and then we have more total electrons. So that's 5, 6, 7, 8 total electrons for oxygen. So you can see that oxygen has 2 pairs in the valence and 2 unpaired electrons. So we only consider the highest n value orbitals. So the highest n value is 2, so we just consider the 2s and 2p orbitals. So we have 2 paired electrons, 2 electrons in an orbital, and 2 single electrons. So for the oxygen atom, we would put 2 dots representing a pair of electrons, and another 2 dots representing the other pair, and then 2 single electrons representing the unpaired electrons. So this would be like the 2s electrons. This would be 1 pair of the 2p electrons. Then these are the unpaired electrons in the 2p orbitals. So I'll draw this over. So I'll have room to draw my hydrogens. Then my hydrogens are on the outside. Now hydrogen just has 1 electron, so I'll just represent the 1 dot coming from the 1 electron on hydrogen. And now what we do is we pair unpaired electrons with a bond. So we can form a bond between hydrogen and oxygen. We'll draw a line for the bond, showing that these 2 electrons are being shared by the hydrogen and the oxygen. So this shows us that there's 1 oxygen-hydrogen bond to each hydrogen atom in water. So this shows us the number of bonds that are existing in that molecule. One other thing in Lewis dot structures, and that's called the Octet Rule. And that is, most atoms want 8 electrons around it, and you can count shared electrons toward both atoms in the bond. Let's write water over again. So let's count the number of electrons around oxygen. We have 2, 4, 6, 8. So 8 electrons around oxygen. Now, you'll notice that we count hydrogen's electrons toward oxygen, but we're also going to count them toward hydrogen. So let's count the electrons around hydrogen. We have 2 and 2. So 2 electrons around hydrogen. Now hydrogen doesn't obey the 8 electron rule, it obeys the 2 electron rule. Basically, every atom wants a noble gas electron configuration. Hydrogen's closer to helium. Helium has 2 electrons. Oxygen's closer to neon, and so oxygen wants a neon configuration, which is a S2P6 or 8 electron configuration. So I'm going to draw oxygen or water over again. So we have 2 bonds, and we have 2 what are called lone pairs of electrons here and there. These do not engage in bonding. They are associated with a single atom and counted only toward the atom. The bonding pairs are counted toward both atoms. Lone pairs only count toward the atom in which they are around.